Hello, this is a video about the different ways to approach solving quadratic equations. Remember that a quadratic equation in x is of the form ax squared plus bx plus c equals 0. This is called the standard form of that equation. And a and b and c are all real numbers, and of course a cannot equal 0 or we would not be talking about a quadratic. There are four typical methods that we use to try and solve quadratic equations. The first one does not always work because not all polynomials that we encounter will factor, but 3 and 4, the methods that we're going to cover the last, those are the ones that will always solve any quadratic equation that you have in front of you. So the factoring method, the goal here is to get the equation into the standard form. You then factor using whatever pattern of factoring that you have, whether it's a trinomial or a binomial. And of course, this relies on it being able to factor. And then we use the zero factor theorem to help us break it apart and solve each piece. The zero factor theorem said that if a times b equals 0, then a equals 0, 0, and b equals 0. So it's telling us that the only way you can multiply to get 0 is if one of the parts or factors is 0. The square root method is for specific versions of equations that look a certain way. In fact, square root method is part of completing the square. So the equation needs to be in the form a squared equals b, and it doesn't have to be just a single variable. It could even be a binomial squared, like x plus 2 squared equals b. And b is a real number. It can be a positive or a negative. We typically teach it to you first as a positive, because we hadn't introduced the imaginary numbers yet, but eventually you can solve it in any form. You take the square root of both sides once you have it in this form, and that gives you that a equals not just square root of b, but plus or minus the square root of b. And if you think about it, that makes sense because if you have 4 squared, that is positive 16, but negative 4 squared is also positive 16. The completing the square method, we try to create what's called a perfect square trinomial, and we'll show you what we talk about when we do one of these in a second. And we'll have some steps on how to do that. And then you use the square root method to finish solving it. So essentially you're setting yourself up so that you'll have the square root method. And there are very specific steps that we follow to do that. The quadratic formula came about when they looked at completing the square with a, b, and c as the actual pieces instead of using numbers. And that pattern that you get when you solve completing the square using those variables still as your numbers became the quadratic formula. So the way you use the quadratic formula, since it's really just something you plug into, is your equation has to be in standard form first, which means equal to 0. You label the a, b, and c terms, which a is always in front of x squared, b is in front of x, and c is the constant. And then you plug them into the formula below, which we're going to talk about in a second, and you solve it. And of course, you have to make sure your answer is in a reduced format, just like anytime you're dealing with fractions. Now, the big question would then be, how do you know which method to try? So these are the steps, and this is just my steps of how I usually walk through this. I first look at what kind of equation I have. So if the only variable in the equation is an x squared, or I see a binomial squared, then my first attempt is actually going to be to try to use the square root method, where I can just isolate the part that's squared and then take a square root of both sides. But you have to have that in that specific format. If you have both an x squared and an x term, you're better off getting yourself in standard form first to see if it's going to fit any of your factoring patterns. If it doesn't factor, then you're down to either completing the square or quadratic formula. And you can use either one unless you have specific directions, but I typically look at the middle term. If the middle term is even and my first term is a 1, completing the square actually goes pretty quickly. If I have a lot of big numbers or fractions, I would probably err on the side of using the quadratic formula. And we don't usually plug it in with fractions, but there is a way to take care of that that's discussed more in class or in an advanced video. So here are the steps for completing the square. The coefficient in front of the squared term, the a term, must be a 1. You cannot complete the square unless you make that a 1. So if it's not a 1, you need to divide every term in the equation by that a coefficient. So if it's like a 2x squared, you're going to have to divide everything in the equation by 2 first. Then we're going to do what we call separating so that we can create that perfect square trinomial. So we're going to keep anything that has an x or the y or whatever variable we're using on the left side of the equation. The c term, or the constant, is going to be moved to the right. To create a perfect square trinomial, which factors nicely into a binomial squared, that's why we do this, you need to take half of the b term and square that value. You then add that to both sides of the equation. Now you're thinking, why is that half b? So this is, sorry, I'm trying to write and talk at the same time. So half of b, which is b over 2 squared, or you can think it of as 1/2 times b squared. The reason we do that is if you look at what a perfect square trinomial looks like, so I'll show you one right here, that's the pattern that it always follows for how the b and c terms are related to each other. So if we have x squared plus 8x plus 16, that factors nicely into x plus 4 squared. This is what we call a perfect square trinomial. It factors into the same binomial twice. If you look at the b term, because usually you don't have the c term when you're doing the completing the square steps, you have a c term that doesn't work, that we've moved to the other side. You look at this and you say, okay, what's half of 8? Well, half of 8 is 4. And 4, you can get to 16 by squaring the 4. So that's why it's half of b squared. So that's just the easiest way to describe that and to show it to you. So then we factor the left side into that binomial squared, and then we'll combine like terms on the right side because we do have to add that number to both sides of the equation to keep balanced. And finally, you finish off with the square root method to solve for your variable, and you don't forget your plus or minus. If you have a choice or you're not told that you have to complete the square, the quadratic formula is pretty easy for most students because it's essentially just plugging and chugging away at the order of operations. So a, b, and c, remember, are terms in your quadratic equation, and you just plug in those numbers and you work it out. So it's x equals negative b plus or minus square root b squared minus 4ac all over 2a. And I usually, when I teach this in class, I teach it to my students by Pop Goes the Weasel, and we sing it. So x equals negative b plus or minus square root b squared minus 4ac all over 2a, because you got to have it memorized. So there's your corny song for that. So let's go through, and I've kind of randomly put these in here. I've put in 5 examples, and we're going to try to determine what the best method is to solve it, and then we're going to work through and completely solve it. So solve the following quadratic equations. So this very first one, I see that it has an x squared, but it also has an x. So I'm going to be stuck with, does it either factor, or am I going to have to use completing the square or quadratic formula? So I would try to get everything in standard form first. So I'm going to add that 16 back over to the other side, so that this is now set equal to 0. And I'm actually going to think, okay, does this factor? Because if it factors, that is the quickest way to solve it. So factors of 16, remember when you factor a trinomial that has a 1 in front, your factors of the c term need to add or subtract to the middle term here. They add or subtract based on if this is positive or negative. So if it's a positive c, that means they have the same sign, so they have to add to negative 10. If this was a negative 16, you would be multiplying a positive times a negative, so that means they have to subtract to negative 10. So my factors of 16 are 1 and 16, 2 and 8, and 4 and 4. Since we have same signs, since this is a positive 16, that means that it's 2 and 8. So this does factor. This would be x minus 2, x minus 8 equals 0. And then by the zero factor theorem, you set each part equal to 0, and you solve it. So this will be x equals 2, x equals 8. Okay, so let's look at number 2. This is w squared minus 8. So w squared is the only variable. So I'm going to try to do this one by the square root method because I don't see a w to the first sign. So I'm going to move that 8 over and make this look like a squared equals b. So once you have it in that format of something squared equals the number on the other side, you can take the square root of both sides. Now, on the side that has the number, we need to put in a plus or minus because we know that w could have been positive or negative before it got squared, and it still would have equaled a positive 8. So this would be w, and this is plus or minus the square root of 8, and we are supposed to reduce all answers. So 8 is a 4 times a 2, and 4 is a perfect square. So this would be plus or minus the square root of 4 times the square root of 2, or w equals plus or minus 2 on the square root of 2. So that, remember, is two separate solutions, a positive 2 square root of 2 and a negative 2 square root of 2. Okay, let's talk about number 3. 2x squared minus 24 plus 18. Right now it's got a 2 that can be pulled out, or you could divide it out of each term since this is an equation. So since there's a left and right side here, we can divide everything by 2. And maybe this will help us determine if we should do factoring, completing the square, or quadratic formula. Because again, I see both x squared and x. So this is x squared minus 12x plus 9 equals 0. 9's factors are 1 and 9 and 3 and 3, and none of those are going to make 12. So this has to either be completing the square or quadratic formula. So I'm going to choose to do completing the square here, and that's because I have a middle term that's even. It's really easy to cut a middle term that's even in half. And I already have a 1 in front since we divided everything by 2, so we took care of that step. So if we look at this, when we try to do completing the square, you keep the x terms together on the same side. I always leave a blank because I am going to create a trinomial over here. We move the constant to the other side, which means it's 0 minus 9, so that'd be negative 9. And I create a balancing blank on the other side so that I remember to add it to both sides. I then take half of the middle term, and the sign does count, at least for the part when we go to factor in a minute. So this is negative 12 divided by 2, which is negative 6 squared, and that makes it positive 36 when we square it. So we're going to be adding that to both sides. So this is x squared minus 12x plus 36 equals negative 9 plus 36. The reason we did this, the whole process of taking half of b and squaring it, is because now this factors nicely into x minus 6 squared, which is something squared. So we're going to be able to use the square root method in a minute. I'd like to point out that that part where it factors, that minus 6, that's what it was right before it got squared. That's why the sign's important. And then 36 minus 9 would be 27. And now we're ready to take the square root of both sides. So if we take the square root of both sides to cancel out that squared, we need to remember our plus or minus on the right side. So square root and square cancel, that would just be x minus 6. This is plus or minus the square root of 27. We want to get x by itself, so we add the 6 over. It's typical that that goes in front of the plus or minus. And then we just have to ask ourselves if that radical is reduced. 27 is divisible by 9 times 3 to be specific, and 9 is a perfect square. So if we break that out, the square root of 9 would be 3, and then we still have the 3 that was the other factor inside. So 6 plus or minus 3 on the square root of 3. So that's what x equals, those two different solutions. Okay, let's look at number 4. Number 4 has something squared. So notice there's no other x's anywhere else. So I'm inclined to try to do the square root method. So to do that, though, you do need to isolate the part that is squared. So I'm going to divide that 2 that's in front of that to the other side. So this would be x plus 3 squared equals 10. And then I'm going to take the square root of both sides again. So square root, don't forget my plus or minus. This is x plus 3 equals plus or minus the square root of 10. We'll subtract over the 3, put it in front. And square root of 10 is 1 and 10 and 2 and 5, and none of those are perfect squares that will help us break that down. So that is our final answer for that one. Okay, my last example here. Obviously, we're probably going to try a quadratic formula because we haven't done one of those yet, but I'll show you why I'm going to go that route. I see a lot of things going on here. There's terms on every side, so I'm going to try, since I do see p squared and p both, I'm going to try to get everything in standard form. So this would be 7p squared, 20p, and then we're going to subtract over the 12, so that's going to be positive. It's not one to save that. So 7p squared plus 8p and then subtract over the 4, and it's going to be 10. Hang on just a second. It is not liking my ink right now. It's not wanting to keep it, so let me move that down. So 7p squared plus 8p plus 10 equals 0. Okay, so my hesitation here to try to do completing the square is, even though 8's even, it's not going to stay even because you have to divide by 7 first all the way across to be able to put this into a form where you can complete the square. That makes this term 8 over 7, which is not impossible to do, but it might be quicker to just go ahead and do the quadratic formula. So a is 7, b is positive 8, and c is positive 10. I am saying positive because if these were negatives, you would need to write negatives down here. So it is important to watch the sign. So it's p equals, since this is not x, negative b plus or minus square root b squared minus 4ac all over 2a. Negative b means opposite of b, so that'd be negative 8 plus or minus square root b squared minus 4ac all over, that means this is all the way across, 2 times a. Okay, so then we work this out by order of operations. So we need to work the inside of that radical first. So 8 squared is 64. So this would be equals negative 8 plus or minus the square root of 64. And then you can multiply those three numbers together. This is negative 4 times 7, so that'd be negative 28, times 10 would be negative 280, all over 2 times 7, which is 14. So this is p equals negative 8 plus or minus. So we need to do 64 minus the 280. 64 minus 280 is negative 216. And that's okay because we've already learned imaginary numbers in a different section. So what we now need to do is reduce this down. So negative 8 plus or minus, now is 216 a perfect square? I don't believe so. No, it's not. So I'm just thinking through my perfect squares, but I think a perfect square divides into it. So let's try 4. Yep, 4 divides into it. There might be a bigger one. 216 divided by 16. Nope. 216 divided by maybe 36. Yeah, 36 and 6. So because there's a negative in front of that, or inside that square root, you know you're going to have an I term. And then 216, we just said, is 36 times 6. So that's going to be 6 on the square root of 6, all over 14 still. And notice that all of my outside numbers are divisible by 2. So we need to reduce this down. So this is negative 4 plus or minus 3 on the square root of 6, I over 7. Now typically when we have an imaginary solution, we break it into its a plus bi format, just like we learned in section that we covered on complex numbers. So this is negative 4 over 7 plus or minus 3 square root of 6 over 7i. And that's the end of this video. Hopefully this helped you, and kind of just main thing is to just look at what you have and try to determine which method is the best one to solve your equation.